Hi everyone, this is Serhan Guner. Today I'm recording a video for you from my office. So I'm going to continue the coverage. We started covering rigid body equilibrium in 2 dimensions, so I have some nice questions for you. So let's get started with the first question. Draw a free body diagram. So that is the question which we are going to solve. All right, not a particularly difficult question. We did more difficult examples in class already. So this is just another example for you. So we like to use single lines for the free body diagram. Unknowns typically use red forces. So we have this force which is called this TC, right? You know, if you want, you can give some names, some letters, A, C, B, right? So that's going to be TC applied at that location. We also have TB, which is from this location. These are cable tensions, only one unknown, right? It's not two unknown. Otherwise, it's going to create more difficulty for you, and you may not even be able to solve the questions if you exceed a certain number of unknowns. Let's put W, which is going to be 200 times 9.81. It's going to be 1962 newtons, right? So that is it. The angle would be nice, definitely, to specify angles. This is 15 degree. What is this? You have this triangle 1.5, 3.6, so just do tangent inverse to get that angle, which is going to be, let me just use my calculator. I have the other angle, so this one is going to be 22.6 degree. And for this pole to be stable, this has to be a fixed connection, and there's going to be 3 support reactions at that point. So I'm going to show. We are not going to find it. If we want, we can find it, but not in this question. So this is AX, this is AY, and don't forget the moment, because it's a fixed support. We covered it on Thursday, and moment. So yeah, that is pretty much it. Free body diagrams are really important. Those are the key components of a successful solution. So this is done. Let's move on. The second one is a crane. Sometimes we just abbreviate it. It's a very common wording. We use it often. So determine support reaction. So the weight, let's just do some shading so that it looks more realistic. All right, so we did similar questions in class. The first step is to determine how many unknowns. As you know, 3 is the maximum number. We are using statics. This is statics. So A is a pin support, so if it's pin, you are going to have 2 unknowns. B is a roller support, so you are going to have 1 unknown, so it's 3 unknowns in total. So what you may want to do is to sketch a free body diagram for this, right? So let's put the weight, which is here. You want to convert this to kilonewtons or weight. It's what's given is mass, which is 2.4 times 9.81, and you are going to find 23. I'm being precise because these are intermediate steps, not my final answer, so I don't want to miss any accuracy. But these, I want to show support reactions. You can make assumptions in terms of directions. If you find answer to be positive, then your assumption, I know there's only one vertical reaction, it's definitely going to be up, right? And if you think about this support reaction has to pull and this has to push, so there's going to be tension at the top, there's going to be compression at the bottom. So if you make a little educated guesses, it would help you, but not required. You can assume any direction. You can assume positive. That is also fine. Let's put this mass here as well. So W is going to be 1.0 tons times 9.81. So it is going to be 9.81 kilonewtons. Just double check. I'm double checking. Did I forget anything? No, I didn't. So that is it. The next step is to apply equations of equilibrium, right? So let's get that applied. So where should I start? I can easily do vertical equilibrium. That's the easy, because AY would be the summation of these and I would be done. So let's get that over with. Summation of Fy equal to 0, right? So based on this, AY minus 9.81 minus 23.544 should be equal to 0, and based on this you are going to find AY to be 33. It came out as positive, indicating that our assumption is correct. This is kilonewtons. Always nice idea, because it's a force is a vector, and you need to indicate magnitude as well as direction, so it goes up, which completes this. Horizontal equilibrium, I can do it and I will see that AX equal to, that's going to be BX, not BY. AX equal to BX, because there is no other horizontal forces applied on the system, right? That's what's going to happen, but I wouldn't be able to figure it out. I need that moment equation first. So let's do the moment equation. Which point should I take the moment? So I'm going with A, point A, because you can also do it B, it doesn't really matter, but let's go with A for this solution. Summation of moment A, make it equal to 0. So again, I typically put my finger to see how things are rotating. Also remember that counterclockwise rotation is positive. This is clockwise rotation, this is clockwise rotation, BX counterclockwise rotation. So I will start with positive, BX times distance 1.5. Again, this is concept of taking moments about a point, and you should have no hesitation with regards to the perpendicular distances when you do that. This is going to be 9.81 times perpendicular distance 2 minus 23.544 times perpendicular distance is 6, equal to 0. I think I captured all. So based on this, BX will, I keep writing BY, there is no BY in this question, BX, if you do this, it's going to be 107.256. It came out as positive, meaning that what we assumed was correct. That is good. And finally, do Fx equilibrium equal to 0. So here you're going to find the x minus ax equal to 0. So based on this, AX will come out to be the same as BX, which is 107,256 kilonewton. However, of course, opposite direction, right? So that is it. We got everything. Of course, for your final answer, just abbreviate. You don't have 5 significant figures in your solutions. This is 6, it's extreme. So just reduce it to I would be fine. 33.3, this is 107.3, this is 107.3. So that would be more than enough accuracy for this question. It's always a great idea to make sure that what you did is correct. You can take moment about point B, and then it should come out as 0, right? So let's do that. Take the moment about point B. AX times, so you can write those down, but of course use the full precision, times 1.5, it's counterclockwise, minus 9.81 times 2 minus 23.544 times 6 equal to, do the math. Let me just do this. 107,256 minus, times 1.5 minus 9.81 times 2. Yeah, so the answer is 0, which is, so it is very difficult to make a mistake with these questions. Otherwise, this will not come out to be 0. So always you can check your results. All right, so that's pretty much it, everyone. Thanks very much for your attention, and I will see you next class. Okay, bye bye, take care.